The cathedral spires of Cologne pierced the grey sky on March 6, 1945, as Pershing Tank No. 301 from Company F, 2nd Armoured Division, rolled cautiously through the rubble-strewn streets near the Rhine River. Behind it, maintaining tactical spacing, came an M4A3E8 Sherman, commanded by Staff Sergeant Robert Early. The Sherman, nicknamed Eagle 7 by its crew, represented everything German propaganda had taught Wehrmacht tankers to dismiss: a 80-ton medium tank with modest armour and a 75mm gun that couldn't penetrate Panther frontal armour at combat ranges. Early's crew had been in continuous combat since Normandy. Gunner Corporal John DeRiggi from Philadelphia had destroyed 4 German tanks in the previous 8 months. Driver-technician 5th grade Clarence Smoyer from Lehighton, Pennsylvania, had kept their Sherman running through conditions that would have disabled more complex machines. Loader Private 1st Class James Bates moved 75mm rounds with the mechanical efficiency of 9 months' practice under fire. Bow gunner Corporal John DeRiggi's brother maintained the Hull machine gun with religious attention to maintenance protocols drilled into them since training. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The city was supposed to be clear. American infantry from the 3rd Armoured Division had reported completing their sweep of this sector hours earlier. But intelligence reports were often wrong in the chaos of urban combat, where German forces appeared and disappeared through cellars and alleyways, with intimate knowledge of terrain that American forces had occupied for mere days. The Americans were moving toward the Hohenzollern Bridge, one of the last intact crossings over the Rhine that Allied forces hoped to capture before German engineers could demolish it. What Staff Sergeant Early didn't know, what nobody in 2nd Armoured Division knew at that moment, was that German forces had positioned a Panther Ausf-G from Panzer Brigade 106 in a carefully chosen firing position 300 metres ahead. The Panther commander, a veteran of the Eastern Front who had survived Kursk, had selected his position with the skill earned through 2 years of combat against Soviet armour. The massive 45-ton tank sat hull down behind rubble piles with only its turret exposed, presenting a minimal target profile while its long 75mm KJK 42L/70 gun commanded the entire street approach. The Panther's sloped frontal armour, 80mm thick set at 55 degrees from vertical, provided protection equivalent to approximately 140mm of vertical armour through basic trigonometric calculation of projected thickness. American 75mm armour-piercing rounds fired from IMED-2 Shermans had proven incapable of penetrating Panther frontal armour at any practical combat range throughout the previous year of fighting in France and Germany. American tank crews had learned through bitter experience that engaging Panthers frontally was suicide. Standard doctrine emphasized flanking maneuvers, calling for tank destroyer support or waiting for artillery support, rather than direct frontal engagement. The German crew believed their position was unassailable. They had destroyed 2 Shermans the previous day using exactly this tactic, firing from hull-down positions where American return fire couldn't penetrate their frontal armour, while their own gun destroyed American tanks with single shots. The psychological advantage German crews felt operating, Panthers had survived intact, despite the mechanical reliability problems that plagued the design. When you could actually get the Panther to the battlefield and keep it running, when fuel was available and final drives hadn't failed and transmissions hadn't seized, the tank was indeed formidable in direct combat. The Pershing leading Early's Sherman rounded a corner and immediately took a hit from the Panther's 75mm gun. The Pershing, America's answer to heavy German tanks, mounted a 90mm gun and thicker armour than the Sherman. But the Panther's round penetrated the Pershing's side armour, the 90mm penetration capability of the German gun at 300 metres being more than sufficient to defeat the Pershing's side protection. The Pershing lurched to a halt, smoke pouring from the engine compartment as its crew bailed out under the cover of building walls. Early immediately ordered Smoyer to reverse, standard doctrine when encountering superior enemy armour, But as the Sherman began backing up, Early caught sight of the Panther's position through his commander's cupola. The German tank was partially exposed, its hull visible above the rubble pile it had used for concealment. The Panther commander had made a subtle tactical error, advancing slightly too far forward in his eagerness to engage the Pershing, exposing more of his vehicle than proper hull-down doctrine required. For 3 seconds that felt like 3 hours, Early calculated odds that every combat experience told him were hopeless. His Sherman's 75mm M3 gun could not penetrate Panther frontal armor. Every technical manual, every intelligence briefing, every tactical doctrine document stated this as established fact. American tanks didn't fight Panthers frontally. They flanked them, called for tank destroyer support, used artillery, did anything except exchange direct fire where the Panther's superior armor and gun made defeat inevitable. But the alternative was retreat, abandoning the infantry that depended on armor support, giving German forces time to establish better positions, allowing the Panther to destroy additional American vehicles as they withdrew down the narrow street where maneuver was impossible. Early made a decision that contradicted every lesson he'd been taught. He ordered DeRiggi to engage. Target, tank, 300 meters, dead ahead. Early's voice crackled through the intercom with the practiced calm of a veteran crew commander who'd learned that panic killed crews faster than enemy fire. DeRiggi traversed the turret, the hydraulic system responding smoothly because Sherman mechanical reliability meant their tank actually worked when needed, unlike German tanks that spent more time under maintenance than in combat. The Panther crew saw the Sherman's turret traverse and recognized the threat despite their armor advantage. German crews had learned that American tankers were aggressive, that they would take chances that seemed irrational, that they compensated for technical inferiority with tactical audacity and mechanical reliability that kept more American tanks in the fight than German forces could sustain through their over-engineered machines' mechanical failures. DeRiggi fired. The 75mm armor-piercing round left the gun at 792 meters per second, armor-piercing ballistic cap ammunition designated M61 in American nomenclature, representing the standard anti-armor round that American tankers had used throughout the European campaign. The round struck the Panther's frontal armor at an angle that should have resulted in deflection or non-penetrating hit. Basic armor penetration calculations using the Desmarais formula that related projectile velocity, diameter, and angle to armor penetration capacity predicted that the M61 round fired from a 75mm M3 gun at 300 meters should not penetrate 80 millimeters of face-hardened armor set at 55 degrees. The round penetrated. The Panther erupted in flames as the armor-piercing round ignited ammunition stored along the hull sides, exactly the design flaw that American engineers examining captured Panthers had identified as creating catastrophic vulnerability to any penetration. The 45-ton German tank that was supposed to be invulnerable to Sherman fire died in a fireball that consumed the crew before they could bail out. Early's crew sat stunned in silence for 5 seconds that felt eternal. They had just accomplished something that official doctrine stated was impossible. Corporal DeRiggi's hands were shaking as the adrenaline surge following the engagement made his body react to stress that his trained mind had suppressed during the crucial seconds of combat. Smoyer kept the Sherman in position, engine running smoothly because Continental R-975 radial engines didn't fail at critical moments the way Maybach engines overheated and seized in German tanks. "Did we just kill a Panther frontally?" Bates asked over the intercom, his voice reflecting the disbelief every crew member felt. Nobody answered because nobody had an explanation for what had just occurred. The technical impossibility had occurred anyway, reality trumping doctrine in a way that would require explanation from people with more expertise than a tank crew possessed. What Staff Sergeant Early and his crew didn't know, what wouldn't become clear until post-war technical analysis examined German armor production during the final months of the war, was that the Panther they had just destroyed represented the culmination of German industrial collapse. The armor plate that should have protected the vehicle had been manufactured in late 1944 or early 1945, when German steel production had lost access to critical alloying elements necessary for proper armor hardening. Allied bombing of Norwegian molybdenum mines in 1943 had eliminated Germany's primary source of this element that increased steel's resistance to penetration. Soviet advance into Eastern Europe had cut off nickel supplies from conquered territories. German metallurgists attempting to maintain armor protection specifications, with steel lacking proper carbon content and alloying elements, were trying to bake bread without yeast, going through manufacturing motions without achieving necessary results. The specific Panther destroyed by Early's crew had frontal armor that appeared correct by visual inspection and met thickness specifications when measured. But spectroscopic analysis that wouldn't occur until after the war would have revealed steel lacking proper alloying element percentages, armor that had been heat-treated desperately attempting to achieve hardness specifications, but had resulted in brittle material that shattered rather than deflected incoming rounds. Some Panther armor plates were properly hardened and would resist penetration as designed. Others were brittle and would crack or spall dangerously when hit. The armor quality lottery made every Panther engagement unpredictable. Early radioed the engagement report to company headquarters, his voice betraying the confusion he felt. Eagle 7-6. Engaged and destroyed Panther, frontal shot, 300 meters. Confirm, Panther destroyed, frontal armor penetration. The response came back immediately, skepticism evident even through radio static. 6 to Eagle 7. Confirm Panther destroyed frontal engagement? The question mark was audible. Nobody destroyed Panthers frontally with 75mm Shermans. It didn't happen. Doctrine said it was impossible. Confirmed, Early responded. Panther burning, crew did not bail out, frontal armor penetration observed. The radio went silent for 10 seconds before company headquarters responded. Eagle 7. Advance and confirm kill. Photographs if possible. Standard intelligence procedure required documentation of unusual combat results for technical analysis. A Sherman destroying a Panther frontally qualified as unusual enough to warrant investigation. Smoyer advanced the Sherman cautiously, the reliable mechanical components responding precisely because American designers had prioritized reliability over sophistication. The Panther was indeed destroyed, flames consuming the interior through the penetration hole DeRiggi's round had created. Early had his bow gunner photograph the destroyed German tank from multiple angles using the Kodak camera that American tank crews carried for exactly these intelligence documentation requirements. What happened over the next 3 hours would become one of the most analyzed tank engagements of World War II, an event that would require explanation from metallurgists and armor engineers rather than simple battle narratives. The engagement that had just occurred was merely the beginning of something that shouldn't have been possible, according to every technical manual and tactical doctrine document the American Army had produced. The second Panther appeared 8 minutes later, emerging from a side street 400 meters distant. German tactical doctrine emphasized mutual support between armored vehicles, positioning tanks to cover each other's fields of fire, so isolated tanks couldn't be destroyed without other vehicles engaging attackers. The Panther commander had seen the flames from his destroyed comrade and was moving to engage the Sherman that had somehow accomplished the impossible. This Panther commander was more experienced and more cautious. He brought his tank into a proper hull-down position, where only the turret front was exposed, presenting a smaller target while maintaining full offensive capability. The sloped turret mantlet, 100mm thick surrounding the gun, represented the most heavily armoured section of the entire vehicle. Penetrating the mantlet with a 75mm gun at 400 meters should have been completely impossible, probability 0, according to armor penetration calculations. Early didn't hesitate this time. The first impossible success had created confidence that overrode doctrinal caution. DeRiggi engaged immediately, the turret traverse mechanism, bringing the gun onto target with the smooth precision of mechanical components that actually worked reliably. The first round struck the turret mantlet and deflected, exactly as armor penetration calculations predicted. The second round, fired 6 seconds later with the practiced speed of a trained crew that had loaded and fired under combat stress for 9 months, penetrated. The Panther's turret filled with flame as penetration ignited stored ammunition. The 45-ton tank that represented German engineering sophistication died as quickly as the first, killed by a weapon that wasn't supposed to be capable of destroying it. The German crew bailed out, 3 men emerging from hatches with their uniforms smoking, testimony to the interior temperature spike that occurred when armor-piercing rounds ignited ammunition. Staff Sergeant Early was no longer questioning what was happening. He was simply fighting, applying practiced combat skills while the technical impossibility continued occurring around him. American tank crews hadn't been trained to understand armor metallurgy or penetration physics. They'd been trained to identify targets, engage rapidly, move aggressively, and keep fighting regardless of apparent odds. Early's crew embodied exactly this training as they hunted for additional targets in the rubble-choked streets of Cologne. The 3rd and 4th Panthers appeared simultaneously from perpendicular streets, a coordinated movement suggesting command-level tactical control rather than individual vehicle action. German armor doctrine emphasized coordinated operations where multiple vehicles supported each other, exactly the tactical situation developing now. 2 Panthers, engaging from different angles, should have been able to destroy a single Sherman regardless of previous improbable successes, overwhelming the American tank through multiple simultaneous threats it couldn't address. Early made a split-second tactical decision that demonstrated the aggressive American armor doctrine that German tank commanders found both puzzling and dangerous. Rather than reversing to cover, which would have exposed his Sherman's thin rear armor to both German tanks, he advanced toward one Panther, while his gunner engaged the other. Smoyer pushed the Sherman forward at maximum speed, the Continental engine responding immediately because mechanical reliability meant American tanks actually performed when needed. DeRiggi engaged the left Panther at 350 meters, while Smoyer was actively maneuvering, a shot that required compensating for vehicle movement and target motion simultaneously. The round struck low on the frontal hull, an area that should have been protected by 80 millimeters of armor sloped at 55 degrees. The round penetrated. The Panther stopped moving as mechanical damage from penetration disabled the transmission or final drive, exactly the vulnerable components that American engineers had identified when examining captured Panthers at Aberdeen Proving Ground. The right Panther fired at Early's Sherman from 400 meters, the 75mm KK-42 round missing by less than 2 meters, as Smoyer's evasive maneuvering threw off German targeting calculations. Experienced crews could hit moving targets reliably at this range, but the Sherman's sudden acceleration had occurred at exactly the moment the German gunner fired, timing that looked deliberate but was purely fortunate. DeRiggi traversed right and engaged the second Panther, 6 seconds having elapsed since the previous shot. The round struck the junction between hull and turret, a structural weak point where armor plates met and welds created potential failure zones. Penetration occurred through the turret ring, disabling the turret traverse mechanism and likely killing or wounding crew members from spalling effects as the armor-piercing round's energy transferred to interior surfaces. 4 Panthers destroyed in less than 20 minutes. The probability of this occurring with 75mm gun against Panther frontal armor should have been effectively 0. Armor penetration isn't random chance, MTA. It's determined by projectile energy, armor thickness, armor quality, impact angle, and penetration physics that German and American engineers understood well. Sherman's 75mm guns didn't penetrate Panther frontal armor because the physics didn't permit it, except apparently the physics were being overruled by metallurgical failure that nobody had predicted. Early radioed the engagement report to company headquarters, his voice now betraying excitement rather than confusion. Eagle 7-6. 4 Panthers destroyed. Repeat 4 Panthers destroyed, requesting additional ammunition and infantry support for area clearance. The response came back immediately, disbelief evident. Eagle 7, confirm 4 Panthers destroyed? The repetition reflected headquarters' inability to accept what Early was reporting. Confirmed 4 Panthers destroyed. Frontal armor penetration on all engagements. Remaining ammunition approximately 30 rounds. Early responded. Standard Sherman ammunition load was 90 rounds for the 75mm main gun, 47 armor-piercing rounds, and 43 high-explosive rounds. 4 kills had consumed fewer than 10 armor-piercing rounds, when ammunition expenditure calculations based on historical data suggested it should have required dozens of rounds to achieve these results, if such results were even possible. Company headquarters responded with orders that reflected senior officers' determination to exploit whatever situation was developing. Eagle 7, maintain position. Additional armor moving to your location. Infantry support en route. Continue engagement as targets present. Command style emphasized aggressive exploitation of tactical success, even when the success seemed inexplicable, exactly opposite of the cautious German approach that would have withdrawn to assess the situation. The 5th Panther appeared 12 minutes later, approaching from the direction of the Rhine River bridge. This Panther's commander had received radio reports of the previous engagements and was approaching with appropriate caution, using building cover to limit exposure while maintaining ability to engage. The German crew knew they faced a Sherman that had somehow destroyed 4 Panthers, information that should have been impossible but was being reported by multiple witnesses. DeRiggi engaged at 420 meters as the Panther moved between buildings, the brief exposure window giving him approximately 4 seconds to acquire target, aim, and fire. The round struck the Panther's side armor, 40 mm thick and vulnerable to 75 mm guns at this range. Side armor penetration was expected and occurred routinely. The Panther stopped moving, smoke pouring from engine compartment as penetration likely damaged fuel systems or ignited hydraulic fluid. The 6th Panther appeared 30 seconds later from the same direction, a platoon-level coordinated movement where multiple tanks provided mutual support. This Panther's commander made the aggressive decision to advance despite the destroyed vehicle smoking ahead, German tactical doctrine requiring counterattack to prevent American exploitation of tactical success. The Panther accelerated toward Early's Sherman, closing range to enable more reliable targeting while simultaneously making German armor advantage more decisive. Early ordered Smoyer to reverse, trading space for time while DeRiggi engaged. The Sherman's simple transmission design allowed rapid direction changes, mechanical simplicity, providing tactical flexibility that more sophisticated German transmissions couldn't match because complexity created hesitation. The first round missed, as the Panther's rapid closure rate made range estimation difficult. The second round struck the Panther's frontal armor at 300 meters and penetrated the by now familiar fireball indicating ammunition detonation. 6 Panthers destroyed. The engagement was no longer following any recognizable pattern from previous combat experience. Sherman crews throughout the European campaign had learned that surviving encounters with Panthers required avoiding frontal engagement, using terrain and maneuver to attack from flank or rear where German armor was vulnerable. Direct frontal engagement produced dead Shermans, not dead Panthers, except today in Cologne, where apparently different rules applied. The 7th Panther emerged from a side alley 280 meters away, extremely close range for tank combat in urban terrain. At this range, even German 75mm high-explosive rounds could damage Sherman armor through sheer blast effect without necessarily penetrating. The Panther fired immediately, the round missing high as Smoyer simultaneously reversed, the combination of German gunner error and American driver skill creating a miss that saved 5 American lives. DeRiggi returned fire 3 seconds later, training and muscle memory taking over where conscious thought would have been too slow. The round struck the Panther's gun mantlet and somehow penetrated, probability calculations suggesting this should occur less than 1% of the time, with 75mm armor-piercing rounds against 100mm thick curved mantlet armor. The Panther's turret filled with smoke and flame as the crew bailed out, their escape demonstrating the tank was disabled, even if not completely destroyed. American infantry were now arriving in the area, drawn by the sound of continuous tank combat that had transformed this sector from supposedly clear to actively contested. Infantry squad leaders directed their troops to cover Early's Sherman, setting up positions to suppress German infantry who might attempt anti-tank ambushes. The integration of infantry and armor support represented American combined arms doctrine functioning as designed, different branches supporting each other's capabilities, rather than operating independently. The 8th Panther appeared 6 minutes later, advancing with a squad of Panzer grenadiers providing infantry support in proper German combined arms fashion. The German commander was attempting the same infantry armor integration that American forces had just established, recognizing that isolated tanks were vulnerable regardless of technical superiority. The Panzer grenadiers carried Panzerfaust anti-tank weapons, shoulder-fired hollow-charge rockets capable of penetrating Sherman armor at ranges up to 60 meters. American infantry engaged the German infantry with rifle and machine gun fire, suppressing the Panzerfaust crews before they could close to effective range. The Panther advanced alone after its infantry support went to ground under American fire, exactly the isolation that made tanks vulnerable in urban terrain. DeRiggi engaged at 320 meters, the round striking the Panther's frontal hull and penetrating through armor that should have provided protection. 8 Panthers destroyed in approximately 2 hours and 40 minutes of combat. The ammunition expenditure was approaching 30 rounds of 75mm armor-piercing ammunition, efficiency that exceeded any reasonable expectation for tank combat against heavily armored opponents. Sherman crews in previous engagements had fired dozens of rounds attempting to destroy single Panthers through flanking shots or lucky hits on vulnerable points, yet Early's crew was achieving consistent frontal penetrations with efficiency that suggested targeting practice rather than desperate combat. The 9th Panther appeared as the sun was beginning to set, visibility declining in the way that made twilight particularly dangerous for tank combat. Reduced visibility made target acquisition more difficult, while also making anti-tank ambushes easier to execute. The Panther commander was using the declining light to approach under partial concealment, professional tactical judgment attempting to offset whatever advantage the American crew had demonstrated. DeRiggi engaged at 390 meters as the Panther moved between shadows, the shot requiring anticipation of where the target would appear rather than simply aiming at a visible target. The round struck the Panther's sloped frontal armor and penetrated the by now routine fireball, indicating successful ammunition detonation. 9 Panthers destroyed in just under 3 hours of combat, an achievement that would require immediate investigation from technical experts rather than simple battle documentation. Early's Sherman had achieved what official doctrine stated was impossible: multiple frontal kills of Germany's most formidable medium tank using a weapon that couldn't penetrate Panther armor according to established ballistic calculations and armor. Penetration physics. The engagement would become one of the most studied events of the entire war, requiring explanation from metallurgists and industrial analysts rather than tactical historians. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Company headquarters dispatched Major Thomas Benson, the battalion intelligence officer, to Early's position within 30 minutes of the engagement's conclusion. Benson arrived with a technical specialist from 2nd Armoured Division's Ordnance Section, a captain who had worked at Watertown Arsenal before the war and understood armour metallurgy well enough to recognise that something fundamentally wrong had occurred with German armour production. The 2 officers examined the destroyed Panthers methodically, photographing penetration holes from multiple angles, measuring armour thickness with calipers at penetration points, collecting armour fragments for later analysis. What they discovered would eventually require shipping armor samples back to Aberdeen Proving Ground in Maryland for comprehensive metallurgical analysis, but preliminary field examination revealed obvious problems, visible even without sophisticated laboratory equipment. The armor around penetration holes showed fracture patterns that indicated brittleness rather than proper ductility. When armor-piercing rounds struck properly hardened steel armor, the metal deformed and absorbed energy through plastic deformation before either defeating the round or allowing penetration. The Panther armor fragments scattered around penetration holes showed clean fractures with minimal deformation, material that had shattered rather than bending, exactly the failure mode that occurred when steel lacked proper carbon content and alloying elements. Captain James Morrison, the ordnance specialist, chipped samples from the armor plate edges with a cold chisel, standard field technique for preliminary metallurgical assessment. Properly hardened armor steel resisted the chisel, requiring substantial force to break off small samples. The Panther armor samples broke away with moderate force, confirming Morrison's suspicion that heat treatment had created surface hardness without proper core strength. "This isn't proper armor plate," Morrison said quietly, examining a fragment under a magnifying glass. The face hardness might meet specifications visually, but the backing plate is showing fracture characteristics consistent with insufficient carbon and missing alloying elements. They're trying to maintain protection standards with steel that fundamentally can't achieve those standards. He looked at Major Benson with an expression mixing professional interest with grim satisfaction. "They're running out of materials. Germany is running out of the metals necessary to make proper armor." The implications extended far beyond this single engagement. If German armor production had deteriorated to the point where Panther frontal armor could be penetrated by 75mm guns, then every tactical assumption about German armor superiority required immediate re-evaluation. American tank crews had been trained to avoid frontal engagement with Panthers specifically because penetration was impossible. If penetration was now possible, even unreliably, then tactical doctrine needed revision. Major Benson ordered immediate distribution of the engagement report through intelligence channels, marking it priority for tank crew tactical bulletins. Within 48 hours, every American armored unit in Germany would receive notification that Panther armor quality had degraded, that frontal engagement might be feasible under certain circumstances, that German industrial deterioration had progressed far enough to affect front-line combat effectiveness. The interrogation of captured Panther crew members from the engagement provided additional insight into German industrial problems. The 3 crew members who had escaped from the 7th Panther were captured by American infantry and immediately turned over to intelligence officers for questioning. The Panther commander, an Oberfeldwebel who had served on the Eastern Front since 1943, confirmed what the armor analysis suggested. "We were told the new armor was as strong as before," he stated through the interpreter, but crews had been reporting problems since January. Tanks that should have resisted hits were being penetrated. Command blamed poor tactical positioning, said crews were exposing vulnerable points unnecessarily, but we knew something had changed with the armor itself. He described receiving their Panther in early February 1945, the tank having been manufactured at Mann's Nuremberg facility during December or January. The factory acceptance inspection had passed the vehicle as meeting specifications, armor thickness measurements confirming compliance with technical requirements. But several experienced crew members had expressed concern about the armor quality based purely on visual inspection, noticing discoloration patterns and surface characteristics that differed from earlier production Panthers they had operated. The technical analysis conducted at Aberdeen Proving Ground after armor samples reached the United States confirmed field assessments with scientific precision. Spectroscopic analysis revealed steel containing approximately 0.3% molybdenum compared to specifications requiring 1.5%. Nickel content measured 0.8% compared to specification requirement of 3%. Chrome content measured only 0.6%, compared to required 1.2%. The hardness testing revealed surface hardness meeting specifications at approximately 350 Brinell hardness number, indicating proper face hardening had occurred. But core hardness measured only 220 Brinell, indicating inadequate through hardening from insufficient alloy content. Proper armor plate required both surface hardness to resist penetration and core toughness to prevent shattering. German armor by March 1945 had surface hardness without core toughness, creating exactly the brittle fracture failure mode observed in the Cologne engagement. Impact testing using standard Charpy V-notch procedures quantified the problem precisely. Proper armor plate absorbed approximately 120 joules of energy before fracture. The German armor samples from Cologne absorbed only 45 joules before catastrophic brittle fracture, less than half the energy absorption capacity of properly manufactured armor. An armor-piercing projectile striking this degraded armor would shatter the plate rather than being defeated by elastic and plastic deformation. The metallurgical failure extended beyond just Panthers to affect all German armored vehicle production during the final months of the war. The strategic implications were profound. German industrial capacity had maintained production output through heroic efforts, but the statistics measured quantity without accounting for quality, counting vehicles that looked like Panthers but lacked the protective capability that made Panthers formidable. The molybdenum mines in Norway, bombed repeatedly throughout 1943, had provided Germany with the critical alloying element necessary for armor steel that maintained strength at high temperatures and resisted fracture under impact. Without adequate molybdenum, German steel producers attempted to compensate through increased carbon content and aggressive heat treatment, creating armor with superficial hardness but insufficient toughness. The armor would measure correctly, look correct, and pass factory inspection, then fail catastrophically when actually hit by armor-piercing projectiles. Nickel shortages created similar problems. Germany had obtained nickel from Soviet Union under the Molotov-Ribbentrop Pact before 1941, from conquered territories during early war expansion and through trade with neutral nations. By 1945, all these sources had disappeared. German nickel reserves had declined to the point where armor steel contained perhaps one-third the nickel content of proper specifications. The strategic bomber campaign's contribution to German defeat emerged clearly from the Cologne engagement analysis. The bombers hadn't destroyed German tank factories directly, but they had destroyed the complex industrial infrastructure necessary to maintain quality, eliminating specialized component suppliers, disrupting the transportation networks, cutting access to raw materials. The result was production without quality, quantity without effectiveness. Staff Sergeant Early received the Silver Star for the Cologne engagement, recognition of tactical skill and aggressive leadership under circumstances where most commanders would have withdrawn rather than engaging superior enemy armor. Corporal DeRiggi received the Bronze Star for marksmanship that had destroyed 9 enemy tanks in 3 hours. The remaining crew members received Bronze Stars for their contributions to what official citations described as one of the most outstanding examples of American armor effectiveness in the European theater. The medals recognized individual achievement, but the broader significance of the engagement lay in what it revealed about industrial warfare's true nature. Wars were not won by the side with the most sophisticated weapons or the most impressive specifications on paper. Wars were won by the side that maintained quality while sustaining quantity, that delivered actual combat capability rather than theoretical performance. German engineering excellence that had created the Panther couldn't overcome German industrial deterioration that had made the armor brittle and unreliable. American engineering pragmatism that had created the Sherman delivered consistent battlefield performance because industrial sustainability maintained quality throughout production. The psychological impact on German forces of discovering their armor protection had failed, exceeded the tactical impact of individual engagements. German tankers throughout the Western Front heard stories of Panthers being destroyed by Sherman frontal fire, accounts that contradicted everything they'd been taught about their technical superiority. The knowledge that their protection might fail unpredictably created defensive caution and hesitation. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The cumulative effect of sustained quality across millions of tons of steel, thousands of armored vehicles, years of production created overwhelming Allied material superiority that German tactical skill couldn't overcome. Even when German forces achieved local tactical victories, the strategic mathematics remained implacable. Allied production replaced losses faster than combat inflicted them, while German production struggled to maintain quantity and failed to maintain quality. The Cologne engagement of March 6, 1945, stands as testament to industrial warfare's fundamental truth, OPA, that sustained production of adequate quality defeats limited production of nominal superiority when actual quality fails to match specifications. Staff Sergeant Early and his crew demonstrated American tactical competence and aggressive fighting spirit, but their success ultimately derived from German industrial failure more than American tactical excellence. The 9 Panthers destroyed in 3 hours represented 9 examples of armor plate that looked correct, measured correct thickness, passed factory inspection, and failed catastrophically when actually struck by enemy fire. The armor had been manufactured by German workers, doing their best with inadequate materials, attempting to maintain specifications through substitution and reformulation that couldn't compensate for missing alloying elements. The final irony of the Cologne engagement lay in how completely it inverted the tactical situation that had prevailed throughout 1944. German Panther crews had entered combat confident their armor would protect them from American 75mm guns. American Sherman crews had approached Panther engagements with appropriate caution, avoiding frontal combat because penetration was effectively impossible. By March 1945, the armor specifications remained identical, but material reality had changed fundamentally. The same 75mm guns firing the same ammunition now achieved penetrations that should have been impossible, not because American ammunition had improved, but because German armor had deteriorated. Germany had entered World War II, believing that engineering excellence and technical sophistication would overcome Allied material advantages. The Panther represented the culmination of this philosophy. The Cologne engagement of March 6, 1945, demonstrated the ultimate failure of this philosophy when industrial capacity couldn't sustain the quality necessary to make specifications meaningful. The Sherman represented opposite philosophy, AIA, adequate rather than optimal performance, reliability rather than sophistication, producibility rather than perfection. American engineers had designed a tank that automobile workers could build, that farm boys could maintain, that would actually function when needed. The philosophy seemed crude to German engineers who valued precision and excellence. The Cologne engagement revealed which philosophy proved correct when sustained through years of industrial warfare. The answer was written in the burned-out hulks of 9 Panthers destroyed by a single Sherman in 3 hours of combat that shouldn't have been survivable, testimony to industrial collapse that transformed German armor from formidable to vulnerable, through metallurgical failure invisible, until the moment armor-piercing rounds penetrated plate that should have provided protection. The engagement stands as exemplar of how wars are actually won when stripped of heroic narrative and reduced to industrial mathematics, ES, through sustained production of adequate quality maintained throughout years of combat, through reliable weapons that actually function when needed, through all the mundane practical details that determine whether armies can fight effectively, regardless of how impressive their weapons appear on paper. Germany lost World War II because German industrial capacity couldn't sustain quality while maintaining quantity, couldn't provide the spare parts and raw materials necessary to keep sophisticated weapons functioning, couldn't maintain the complex infrastructure necessary for modern mechanized warfare. The Cologne engagement compressed this industrial failure into 3 hours of combat, where every German weakness and every American strength appeared with unusual clarity. One Sherman crew destroyed 9 Panthers through combination of tactical skill, aggressive leadership, crew coordination developed through months of sustained operations, and German armor plate that shattered rather than deflecting armor-piercing rounds. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The lesson remains relevant decades after the engagement. The principle that adequate performance, sustained reliably, defeats optimal performance that can't be maintained applies far beyond military equipment. The Cologne engagement teaches through specific historical example what remains true across all applications: that the best solution is not the most sophisticated solution, but the solution that actually works when needed, maintained at adequate quality, delivered in sufficient quantity, sustained throughout operations, regardless of how long those operations continue.